So, all right, it says it's live, so we'll
Perfect.
see. All
So this is my first one of these. I joined the class the Monday, the last day to add the class, and so I missed the last one. So are we just supposed to go over like the it shows like problem number in doc is 1, 2, 3, like just go through those?
Yeah, pretty much. So this is like, because like last week it was just like you just posted the discussion board, and then it was just like if you had questions or whatever. So.
This is actually the first time that we've done this whole video thing, so it's new for all of us.
Yeah.
Okay.
So we just have to like, and then so we're gonna talk through the questions, and then we just submit a copy of the questions, and then submit a copy of the video, and then do the participation.
Okay.
Yeah.
So in the future, I don't mind, being the one to write them out. But this time, if you guys are done, if we're not done by the time I have to go to work, then I'd have to email you the first half or something. So who's going to be doing the, like, writing it down and submitting it?
I can do that.
Okay.
Are you guys meeting up at like 2 for now on?
I think that would be better for me because I mean 3 to 4 is okay, but then that kind of cuts it close. I still have to get to work.
Yeah, I get out of class at 1:45, so that's just a sort of a meeting right after that. I don't have an hour awkward gap of nothing. So
yeah, I'm pretty chill, honestly. I get done at 12:30, so I'm gonna have a gap anyway, so I don't really care.
Yeah. On Wednesday, I don't have any classes except for online classes, so we're good.
So I'm a bit confused about this. So were we supposed to go through and do all these by ourselves, and we're just supposed to talk about and make sure we all agree and ask questions? Or are we supposed to like actually go through them together and solve them together like we haven't done them before up to this point? Does that make sense?
Yeah, the idea is we do them all like separately.
Yeah.
And then we just have them all done, and we bring it to this meeting, and just talk about it.
That's quick. Okay, perfect.
Yep. All right.
This is what's killing me. See, I'm in 3 different online courses. 2 of them are actually pretty easy. One's English 301, and the other one is biostatistics. But when you get to this, it took me like 30 minutes to find the document that he was referring to that you're supposed to download.
Yeah.
And I'm like, what the heck are we talking about? So let's go.
I agree. But all the documents are in weird places. It's been taking me a long time to find stuff too. Like there's no logic behind where stuff is.
No. It's like obscure links that you just have to like magically find.
Yeah.
Yep. Okay. So for question 1, I am closing out some of my. I need to keep this one open. Let's see. I had this open just a minute ago. So next time this is going to be much faster, but now I'm lost. Where are my?
What do we already messaged Winnie? You win? You win, Mama? You win?
Sorry, guys. You get in.
Mama?
I can go upstairs. It's all good. So That's okay, babe. We're fine. There we go. You guys ready?
Let's do it.
Okay.
Okay, so just problem 1. So I guess we'll read it. So if you take 2 steps of different sizes, you can end up at your starting point. More generally, can 2 vectors with different magnitudes ever add to 0? Can 3 or more? So what do you guys think?
I think that 2 vectors with different magnitudes cannot add to 0, but 3 or more could. But if they were the same magnitude, of course they could, because you could have one vector going one way, the other vector going a different way, and that could be 0. But if they're the exact same magnitude, it would be, it wouldn't be 0. It's impossible, in my opinion.
Right.
So, okay. I'm sorry then, guys. I am not in the right spot. I thought it was talking about going to the OpenStax and getting the question from here, but you guys are reading something else. So, for your convenience, the group work problems are all provided you in the document you downloaded, which I was figuring was the PDF that we downloaded.
Yeah.
Isn't it just the
I think it
group work week 3 sheet? There's like 10 problems.
My goodness, it's right there. I have it. Okay. I went through a different set of questions, and now I'm feeling stupid.
Oh no.
Okay. I'm
That's
sorry.
okay. That's okay. It's like the first week, so who cares?
Okay. So if you take 2 steps of different sizes, can you? That answer is no, because you're correct. If they're different sizes, then I would think that you cannot. And 3 or more could. I agree with that.
Yeah.
Okay. So 2, you walked 18 meters. So this, we would just, tell me if I'm wrong, we just do a squared plus b squared equals c squared, because, right, you're going west and then north. And so where you are would be just the end of the hypotenuse, right? Or am I off?
Mm-hmm.
That's what I did, yeah.
Yeah.
Yep, so that's like 30.8 meters, right?
I don't know.
Yep.
I'm behind.
It's just 18 squared plus 25 squared.
And the square root of that answer. 30.81, right?
30.8. That's
Oh, that's right, because it's sig figs. Yep. Okay. And if I would have scrolled down more, I would have seen the R there showing exactly what it was already. Silly me. Okay. Find the magnitudes of plus the same.
All right, are we good on 2?
Yeah. I'm moving on to 3.
Yep. So what'd you guys get on 3? Or you, Michael, I guess.
Did it late last night. I'm trying to understand what I wrote. Would one of them be like 3.94 and the other one 2.78?
Yes, I think so. I got 3.94 for one of them, and I got 3.45. But this one kind of gave me trouble, so I'm not sure. I need to double check the other one.
Yeah, I'm trying to figure out how I did it. How I got. Let's see. Okay, so one of them would be 3.94. To get the other one, I took 6.72 and subtracted 3.94, which wouldn't be correct.
No.
So I only found one of them. I also needed that same process to find the other one.
Yeah, so you could take 3.94 and then substitute it into like the Pythagorean theorem. So it'd have to be squared, and then you have like a b squared, and then your c squared is the 6.72.
Right, yeah, that makes sense. 3.94 plus like x squared equals the 6.7. Yep. Okay. Stupid mistake. Got it now, though.
Okay. So I am still doing. So you guys found the B first, VB, or VA?
Yeah, so the way that you can do it is set up like a system of inequalities with A and B. That's one way to do it.
I think to find the one side, I used the law of sines, and that worked.
Yeah.
There we go.
So we all pretty squared away on number 3.
Yeah, 3 were good. Okay. Suppose you add 2 vectors A and B. To the greatest magnitude.
Okay, so number 4 says, suppose you add 2 vectors A and B. What relative direction between them produce the resultant with the greatest magnitude? What is the maximum magnitude? What relative direction between them produce the resultant with the smallest magnitude? What is the minimum magnitude?
Okay. So just the first one. So what would produce the greatest magnitude?
So wouldn't that be 2 with the same direction? And wait, see.
Yeah.
That's what I put down. Yeah, with basically zero angle, just 2 basically in a straight line. Is the resultant? Wouldn't that just be the 2 of them added together? That's the max resultant you could possibly have.
Exactly. The more.
So they'd have the same.
Yeah. Go ahead.
Yeah, same angle, and then whatever the length of them.
Yeah. So no matter, if you have 2 with, a 4 and a 5, the best is of course to be the same angle. What relative direction between them produces the resultant with the smallest magnitude, which would be obviously if they had not compromised, but anyways, if the angles were the exact opposite, if they were inverse, right?
Mm-hmm.
So if you have a 90
in
and
the opposite
180.
direction, so they're going against each other. Yep.
What's the other question? What is the maximum magnitude? A plus B. Right.
Mm-hmm.
What is the minimum? A minus B? I don't know. It's kind of a
A
weird
plus
way.
negative B. Yeah.
It's weird given like answering in like I'm used to word problems, but not answering in word answers. Like, you know, A is 3, B is 4, and then you could answer in numbers. That's weird though. Okay.
Right.
So is that what we needed to answer there?
Yeah.
Okay.
And then yeah. Yeah, it's just a conceptual idea.
Okay. And 5. A new landowner has a triangular piece of flat land she wishes to fence. Starting at the west corner, she measures the first side to be 80 meters long and the next to be 105. These sides are represented and as displacement vectors in figure 3.61. She then correctly calculates the length of the orientation of the third side, C. What is her result? Okay.
So I got 151 for C. I don't know if it's right or not.
That could be. I got 74.77.
Okay.
This one was, yeah. How'd you solve it, Michael?
So I broke A and B up into their components. So AX I have as 80 cosine of 21. AY I have as 80 sine of 21. And then BX I have as 105 sine of 11. BY I have 105 cosine of 11. And I took I added the two X's and the two Y's. And that gave me an exponent of 74.4 and a y component of 131.74. Then I did the Pythagorean theorem, root, and that gave me 151.
See, the thing that was getting me is I was thinking that that C would be larger than A but smaller than B. I'm not sure why. I just started looking at it, and I'm.
It looks like it should be. I agree with that.
But they don't always do it as it should be. So
yeah, those numbers could just be thrown out of thin air. So
yeah.
It's not always to proportion.
So how did you get your answer? Actually, did you say 92?
For what?
C? What did you get for C?
74.77.
Oh, okay.
I don't think I added them right. I think I mixed them up. I think I mixed numbers up. So I think what you got, because I'm just looking back over what I did, I think I mixed them up. So I think what was it? Whatever you got for C, I think was right. Okay, so what did you get for AX plus BX? Just write these things down.
74.4 plus 131.74.
30 point what?
Oh, sorry. You mean the different components?
Yeah.
So AX, I got 74.68.
Okay, one sec. 74.168.
74.68.
Okay.
And then BX, I got 20.03.
Yeah. Okay.
And AY, which is 80 sine of 21, I got 28.67.
And then BY.
BY 105 cosine of 11 is 103.07.
And then AX plus BX is
74.4. Whoa. No, it's not. Let's see. Oh. Why?
yeah, that should be like
Is that
94.
1.74? $94.71.
And then the Y's.
Y 103.07 plus 28.67. 131.74.
Okay. And then C will get you take those by the yeah. So I got 160.9 feet. T.
Yeah. Or some down wrong. Okay, perfect. Do you guys think that's right? Like, is that?
So I am just finishing up. I'm just trying to do it myself because I like to make sure I'm understanding it. But
Right.
divided by times.
Okay.
Here's my thing. So we have north, south. So I'm using the law of sines, but we don't know the actual inside angle of any of them, or we could find. I'm just confused because using the law of sines or cosines, like if we know the angle between C and A, like how do we find the angle of zero, like the question mark there? Because then we could find out the rest. But
So I went. Go ahead.
we can go ahead and go with that answer because I don't want to take up. I only have like another 9 minutes before I have to hurry up and skedaddle. But I'm confused on, like, I'd like to remember how to do this. I'm missing something because if I had one more piece of information, I just have to remember how to.
Yeah. I'm just wondering about like the adding, because we might be, because like if you select C, if you treat that as a hypotenuse and you make the y-axis as one of them, and then do a horizontal line, that'll be you'll have a right triangle and that little space. And then we could use trig for all that stuff.
Okay.
Because then you could.
But see, the hypotenuse only works on a right triangle.
Right.
So here's my.
So you'd have to make.
Okay. Well, tell me if this makes any sense. It just kind of dawned on me that it might work this way. So if you look at A, that angle is 21 between being a. So it's a 21 degrees south of east.
Mm-hmm.
And then you have, it does show that B is 11 degrees west of north. And so if you get those two together, you can find out the angle. That is enough information to find the angle of A and B, and you can use the law of sines, the law of cosines to find C, right?
I just did it the way that the book talked about the A plus B plus C equals 0. Just break it up into the components, and it gives you all the angles you need for those components. So like the vector A, you're given the angle 20, so the x component for the vector A would be 80 cosine of 21, and the y would be 80 sine of 21. Then you just add those up. That's the way the book talked about doing it. So just the way it seemed easiest to me, but I don't know.
Well, if you're doing it that way, and that's great, wouldn't y be, because on the y scale it's a negative. Does that not play into account here? Because you'd be a negative y scale because it's below the x-axis.
Yeah, I'm not sure. I wasn't sure about that one either.
I think you're right, but I think you would need to do a negative sign of 21.
The y would be a negative rather than a positive.
Yeah, but I don't know.
Yeah, so you just change the signs.
But yeah, I don't know. I guess we do need to keep going though. It's 3:40.
Sorry.
So.
Yeah, I'm sorry, guys. Next time I will make sure I am as prepared as can be. So
no, it's all good.
Okay, so it's 15 degrees. Number 6.
All right, so if we're moving on to number 5.
You mean 6?
6.
Oh, okay. Just like, oh no. Okay.
So did you guys get 64.8 as the resultant?
Yep.
Perfect. And theta is 49.1.
Yep. Totally didn't do theta. So yeah.
Perfect. It's just the inverse tangent of y, 48.98 over 42.4 or something.
Okay.
It was what? What was your answer for theta?
Oh, sorry, 49.1.
9.1. Cool. All right. So number 7.
I had a hard time with 7. I still don't understand it.
So, what did I do there? Yeah, so I just had to look up the formulas for it. So one of the formulas, and like after figuring out the formulas and stuff, it was pretty, like, I guess just pretty cut and dry. You just plug it in. So for part A, the formula is, so
Isn't that one the Vx equals VO? Let's see. Sorry, not X. It's V times. Never mind. It's V.
Yep. Okay, yeah. So like to get the range for the first one, it's just the range as an like R equals V squared divided by G times the sine of 2 theta. And I just pulled that from the lab. It was just on there. So then that gives a degree of 14.7.
Okay.
Perfect. So what other angle gives the same range?
So I think it's just the, if you like subtract the 14.2 minus 90, I think that's the same range. So, but it wouldn't give you the same, like it would be in the air longer. So if you're throwing the football at a different angle. So they're saying it hit the same spot, but it would just have a lot more air time as it fell.
It'll give people more time to actually. Okay.
Yeah. So you want it as quick as possible. So that's why you wouldn't use the big angle.
Perfect. And then how long did this pass take? Guess if you have the angle, you just throw it in the time equation. And so what is the time? How long did this pass take?
I got 0.6.
Okay, cool. right, perfect.
Yep.
So for 8 on A, what is the height of the cliff? I don't know if I'm right, but I thought it was 24 meters.
I got 27. What did you use?
So the equation I used, I put down 1.5 equals h for the height of the cliff plus 25.98, which is the y component, 30 sine of 60, 25.98, multiplied by 4, 4.9 times 4 squared. I don't know if I put something in the wrong spot in that equation or...
I'm not sure.
What did you do?
So I did what did I do? I did the height is equal to 1.5 plus 30 times sine 60 times 4 minus 1/2 times 9.8 times 4 squared. And I pulled that from, where did I pull that from? Oh, just the y. So I pulled it from the equation of y equals y sub 0 plus the velocity of 0, velocity sub 0, sine of theta times t minus 1/2 gravity times t squared.
Mm-hmm. Yeah, that's the equation I also used.
No. So I have to go, but did you guys get the height? I was just going on just to see if I could do anything while you're doing those ones. Height from the ground to the cliff, I had as 35.94. Is that what you guys, or did you guys already say that?
Yes. So that's the height of the trajectory. The maximum height it gets is the 35.94.
Maximum height. Dang it.
Yeah.
Okay, that's right.
That's not the height of the cliff. That's the height of the.
So that's right. And the height of the cliff, is that the 34.44? I'm getting these. Let's see.
Yeah.
Okay. Well, I'm sorry. I don't know if I'll get full credit, but I've got to go. So.
So where do you guys want to meet up on campus?
I don't know, someplace in the library probably. Maybe
yeah, I was thinking the library would be good.
Yeah.
Because there they have plenty of different study rooms.
Right.
So we could always do that. But
we'll just keep in contact through email and maybe
okay.
Email everyone our phone numbers and just text or something and meet up in the library and find some place or something like that.
Well, thank you all. You guys have a great day.
You too.
You too. Take care.
And Michael. Bye.
Okay,
right.
so on that equation, the y equals y naught plus v oyt, that one, that is the equation you used, right? Number 3 from the background materials. Okay.
Yeah.
So trying to figure out what I did wrong. So y, isn't that like the initial height, like where you're starting off of?
Yeah, y sub 0.
The y in y.
Oh, the y. That's the. That's finding the. Like the ending height.
Okay.
That it starts at.
Maybe that's what I did wrong because I did 1.5 equals h. Is it like y equals 1.5 plus 25.98? Okay.
Yeah, so you just switched them. That's all.
Perfect.
So.
Okay, beautiful. I wish you'd give us like the answer so we know if we do it right or not. You know?
Right? Yeah.
That way we could learn. So
Yeah. I've had some classes where they actually post the answers.
yeah.
But-
I think that's how it should be. And we just show the work on how to do it. That way we know we
Yeah.
do it right. I don't know. It is what it is. Okay,
It's
so
with
arrow's
C.
impact speed. What did you get for that?
So I got 20 meters per second.
How did you get that?
So I took the two components of like finding the velocity of the y and the velocity of the x,
Okay,
and it did the whole Pythagorean theorem square root
so it's 25.98 plus 15.
stuff.
Is that right?
The y.
Is it 25.98 plus 15 squared?
No, it's I got negative 13.22 squared plus the 15 squared.
So isn't so you got negative 15 for the y component?
Negative 13.22.
13. Isn't that just 30 sine of 60? Or
Plus
25 point.
where did I get this? Yeah, I looked this one up online because this one I wasn't even sure about.
Yeah.
So they're saying using use the like the same formula basically that we used to find the maximum height, but you leave off the delta y.
Okay.
So it's vy sub 1 squared will equal vy sub 0 times sine of theta, and that's all squared, and then minus or plus. That should be a minus 4 times 9.8.
Okay. Perfect. So should we move on to 9?
Yeah.
Okay, if someone's riding the back of a pickup truck and throws a softball straight forward or straight backward, is it possible for the ball to fall straight down as viewed by a person standing at the side of the road? And then under what conditions would this occur? How would the motion of the ball appear to the person who threw it?
So I said that was possible. You would just have to throw the ball with the same velocity that you're traveling backwards with the truck.
And
so then those would cancel out, and so it would just drop down.
Basically, right?
Yeah.
Yep. And what was the other question? How would this motion of the ball appear to the person who threw it? Basically, just drop down. Like, I don't even know what they mean by that one. Right?
Yeah, so it's like the person standing in the truck. What would it look like to them? So from the position of the truck, it would actually like kind of go out and dip down into the road.
Yeah.
Just like you threw a ball like normal.
Right, yeah.
Because you're not affected by the velocity of the truck.
Okay, perfect. Easy one.
Yep. That's it. Oh, done.
So,
Just kidding.
One more on 10.
So an athlete crosses a 25-meter wide river by swimming perpendicular to the water current at the speed of 0.5 meters per second relative to the water. Reaches the opposite side at a distance of 40 meters downstream from a starting point. How fast is the water in the river flowing with respect to the ground? What's the speed of the swimmer with respect to a friend at rest on the ground? So this one, like I started with figuring out how long it took him to get from one side of the river to the other side of the river. And I got 58 seconds with that. And then using that, found the velocity of the actual, what was it? The X component, so like along the bank, like the 40 meters. And then having those two velocities, I was able to find the velocity of the diagonal, basically.
And what'd you get for the velocity of like where he actually swam the diagonal?
So that was 0.852.
Okay.
Or 0.9, I guess.
Is that meters per second?
Yeah.
Okay. Yeah, I did it different, but I didn't really understand what it was asking. I got a little bit confused on this one, so basically what I did, not knowing really what is even asking, is I basically drew the triangle that the x was 25 meters, or sorry, the y was 25 meters, the x was 40. Then I just got the hypotenuse of that, which would be, what he actually swam with the Pythagorean theorem. Is that completely off?
No.
Basically, I guess I'm a little bit confused on what it's even asking.
Yeah, so you're totally just like right on. Because the 25, yeah, is how across it is. 40 is the length of it.
Right. So it'd be 47, the hypotenuse, right? Like that's what he actually...
I actually never found that out. Yeah. But, yeah.
Then knowing that he swam 47 meters and knowing that... let's see, does it say... Let's see.
Oh, man.
So was he swimming 0.5 meters per second? I think that's what confused me. That's how fast he was physically swimming across.
Yeah, so he's swimming 0.5 meters across the river. That's his speed to go across. So it would be the 25. Oh, that should be 50. But yeah, so 25 meters across, he's swimming at 1.5 meters or 0.5 meters.
Okay, so he's swimming 0.5 meters a second across, going on the 25 meters, not on the 47 meters.
Yeah.
Okay, that's why I screwed up then, because I based it off of the 40.
The answers I gave you aren't even right. I just realized I messed up a number.
Oh. Okay. Yeah, cool. That's what I did wrong. Yeah, I got different numbers, but that's just because I took it off the 47 rather than the 25. So. All right, perfect.
Pretty cool. Well, have a good week.
Hey, you too. It'll be nice to actually meet up in person and actually be able to explain what we're talking about a little bit better rather than on the stupid computers next week. So.
Seriously. We've got to find like the whiteboards. I love the whiteboards.
Yeah, I agree. All right, man. I'll have a good week.
Out. You too. Have fun.